Hello, this is John from caveofprogramming.com. In this tutorial we're going to look at constructors and destructors in C++. A constructor is a special method that runs when your object is instantiated, and the destructor is a special method that runs when your object is destroyed. So when you create an object, when you create a specific cat, in the example I've been working with from your cat class, that's when a constructor runs. And when the memory for that object is deallocated, when the cat is destroyed, that's when the destructor runs. So let's take a look at that. I've created a main function here, and I've put two couts in it. So one's right at the start and it says starting program, and one's right at the end just before the return and it says ending program. So if I just run that now, it's just going to say starting program, ending program. I've also created a cat class like we had in the last tutorial. I've given it a private, I've been calling this a data member, and it's actually a specific kind of data member. It's an instance variable, because as we'll see in future tutorials, this happy thing here, every single cat that we create from every particular cat, every particular object that we create from the class will have its own version of this happy variable. So every cat could either be happy or sad, but we'll get onto that in future. So this is an instance variable of type bool, which I've called happy, and we've given it a method called speak, like in the last tutorial. And all that does is speak just looks at happy, and it says if happy is true, output meow. Otherwise, if happy is false, output like a distressed cat noise, angry cat noise. And you'll notice here that in the last tutorial I actually initialized happy. I set it to true or false, and here I've removed that initialization, so we're not setting happy to anything. And it's an interesting question just to start off with, and this is relevant to what we will talk about in a minute. What's going to happen if we run this program? What value will happy have? Let's go to the main function here, and I'm going to create a cat, let's call it Bob. So this is called instantiating. We're instantiating a cat from the class. In other words, we're creating a particular cat object to represent a particular cat from this blueprint, the cat class. And let's call bob.speak. So if I type just .s and do control space, the autocomplete just completes it for me. That was just holding down control and pressing space after typing the first few letters there. Let's run this, and it actually says, well, we've got an error here. Yeah, I forgot to put the include file in. I always forget that. Fortunately, the compiler catches this kind of error. So let's do include cat.h, because we need to include cat.h in any file, any CPP file, or even a header file where we refer to the cat class. So in this cat.h, we're defining the cat class. So obviously we don't need to include cat.h in cat.h. That would be recursive. You know, your program would never compile, even if it allowed you to try to build it, which it might do. I don't know. I've never tried it. But in cat.cpp, where we're supplying the implementation of the cat class, the actual guts of it, the actual code that does stuff, there we need to include cat.h. And also, because I'm using that cat class in the main function, I need to include cat.h there as well. Otherwise the compiler just won't know what it is. Okay, let's build that. I'll use the shortcut, and on the Mac it's Control B to build all projects. Actually that's a bit lengthy. Maybe I should just build a particular one. But anyway, let's run that now. And it says so it's saying and if we look at the implementation here, that suggests that happy is false, because otherwise it would have said meow. And in actual fact, in C++, the instance variables like this bool happy are not initialized automatically. You have to give it a value. And if you don't do that, it's just going to have whatever garbage happened to be in the bit of memory that was allocated for this Boolean variable. So for whatever reason, in the bit of computer memory that this is using, there happened to be like a 0, or the equivalent of a 0 for a Boolean. and that's why it's false. But it could just as well have been it could have been the equivalent of true. There could have been a 1 in there, and that might change depending on what programs you run and what happens with your operating system. So you must initialize variables. But as we saw in the last tutorial, at least in Eclipse CDT here, if I set this equal to true, we actually get a warning. Let's just save that and build it. It's probably not going to appear now. I've actually upgraded my Eclipse here to the latest version, which is Lunar at the moment. If we look at that, it says initialization of non-static data member, in-class initialization. So basically, we're going to look at static data members later on. This is a non-static data member. It's also known as an instance variable, and we shouldn't be initializing it in the class is what it's telling us, although that will run and it will compile and it will say meow, as we should expect if the cat is happy. So where should we initialize data members then? Well, a good place to do it is the constructor. So to create a constructor, which is a method that will run when we instantiate the class, let's go to this public section. Now, usually the convention I've chosen to follow is that I start my variables and my function names, my methods, because we remember, a function and method if it's part of a class. I start them with a lowercase letter, but I have to make an exception for constructors and destructors because they must have the same name as the class, and that's cat with a capital C. C++ is case sensitive. So I'm going to type cat here, round bracket, semicolon. And another thing about constructors and destructors, and this is a constructor, is that they don't have a return type. So all of the functions have a return type, even if it's void, which means that it doesn't return anything. That's still a return type. It just says this returns nothing. Constructors and destructors can't return a value, so they don't have any return type, not even void. They have nothing there. So all you need is the name of the class and round brackets like that with a semicolon. Let's define this constructor. Let's implement it. I'll go to cat.cpp and I'll put this above my other functions just because it's a logical place to do it, but you can put them in any order actually. So let's say here cat, remember no return type, colon, because we need this to associate the function with the actual cat class. And cat, which is the name of the function, it's the constructor. So in this case, it's the same name as the class, round brackets, open and close the curly brackets. Let's have a C out, and let's say here, cat created. And underneath that, I'm also going to set happy equal to true, rather than setting it when we actually declared the variable, because that was, as we'll see later on, that's kind of a bit of a useless thing to do. And the proper place to do this is in the constructor. So we've set happy to true, and that's going to run. If we look at the main function, it's going to run at this point here when the actual object is instantiated, when the cat is created from the class. Let's run this. A particular cat called Bob is being instantiated from the class. So it says starting program, that comes out here. Then we instantiate the object, and it actually says cat created because the constructor automatically runs at that point. Then it says meow because we're running the cat.speak, bob.speak here. Then it says ending program, like that. We can also define a destructor which will run when the object is destroyed. So let's take a look at that. We'll go to cat.h, and a destructor is exactly the same as the constructor, like that, same name as the class, must be in the public section, except that it has a tilde at the start, so I'm going to put a tilde here, like that. And then we need to define that. Let's go to cat.cpp, and I'll put this below the constructor and above other functions, just because again it's a logical place to do it. It doesn't have to be there. And again we need the name of the class, colon, then the name of the particular function, which in this case is tilde cat, because it's the destructor and it has to have the same name as the class, and it has to have a tilde in front of it. And let's just put in there cat destroyed. So I'll run this and it will build automatically. And what's happening now, let's compare the output with the main function here. So it says starting program, cat created, that's at this point, then meow, then ending program, and then it says cat destroyed. Now the reason for this is that if we declare a variable like this, if we instantiate an object, we say the scope of this variable is the nearest pair of enclosing curly parentheses, curly brackets, which are these. So that's the scope is the region in which this object exists and in which we can actually use the variable. And so when we hit this closing curly bracket here, at that point the object will be destroyed. The memory associated with it will be given back to the operating system so that other programs can use it, and so that your own program could use that memory for something else potentially. And at that point the destructor is called, and that's why it's coming out just here after the last lines of the program. We can actually change that. So usually curly brackets are associated with a statement, like a function statement like here, or an if statement or a loop or something like that. But we can just gratuitously use curly brackets in our program if we want to. And that's not very common to do, but sometimes it's done just to specifically deallocate memory at a specific point in your program. So I'm going to put curly brackets before and after, before where we actually declare the cat object, the cat variable, before we instantiate the cat, in other words, and after the last point where we use it, which is when we call speak on it here. And let's just use the formatter shortcut. So it's Command-Shift-F on the Mac or Control-Shift-F on Windows, I think, to actually automatically format this. Remember, we've got to indent between curly brackets, and these are no exception. So this looks a bit strange and it's not very common, but we can do it. And now what effect this is going to have, it's going to mean that cat only exists between these curly brackets. So after the closing curly bracket, because we declared it within these curly brackets, we can't now do stuff with Bob. We can't call bob.speak again down here, because it's outside the scope of this variable, which is just here. We can't do that. And also the memory associated with this object is going to be deallocated. In other words, the object's going to be destroyed. The particular cat will be destroyed when we hit this closing curly brackets. I don't like to talk about cats being destroyed, but it's not a real cat. So let's just run that and see what happens. And remember, in the last version we had of the program, it said cat destroyed after ending program, because the cat was destroyed when we hit this closing curly bracket. That's where the object is destroyed and the memory is deallocated associated with it. Let's run it now and see how that changes. So now everything is as before. Starting program, cat created, meow, but then it says cat destroyed. It says that before ending program, because the object is destroyed when we hit this closing curly bracket here, before we hit this line here. So I'm going to leave it there for this tutorial. And to practice this, what I'd recommend is define a class of your own. Give it at least one function. Give it at least one data member like that. Then add in a constructor and actually type it out yourself, because when you create a class, if I right click the project and go to new class, you can just tick these to automatically generate constructors and destructors. And if you have a lot of trouble getting them working, it's worth just trying that so you can see them working. But it's really, really important to type them out yourself when you're first starting, because that will really help you memorize what they look like. And if you don't do that, you'll sort of tend to forget things like the exact formatting. You'll forget that it's case sensitive, or that you need a tilde or a semicolon, or you'll put it in the wrong place or something. So it's very important to type the constructor and destructor out yourself. And when you've done that, I'd recommend initialize any variables that you've got in the constructor and actually use them in a function that you define. Use them to do something so you can see that their value is what you expect it to be. At the very least, just output them in some method, output the value of them. And also put statements in your constructor and destructor just so you can see when they're run. Build that program and try putting curly parentheses around the instantiation of your object, around the, limit the scope of your variable a bit more with curly parentheses and see what effect that has. And the great thing about doing all this yourself, even if you have to keep referring back to an example program like this one, which is normal, but the great thing is that you do uncover any weak spots in your understanding, and you might end up kind of scratching your head for some time, but eventually you'll see what you're doing wrong, and the longer you puzzle over it, actually, the better it ultimately sticks in your mind. So it's really a good thing to do, even if it's a little bit frustrating to type all that stuff out at first. It's well worth doing. So that's it for this tutorial, and until next time, happy coding.